Dear all, through this lecture we are again continuing the properties of continuous time Fourier transform. The 11th property of CTFT is the multiplication property. Actually it is a reverse property when compared to convolution. So we know that according to convolution property, the convolution in time domain, performing convolution operation in time domain is equivalent to performing multiplication in frequency domain. Okay, so here the property statement is that if x of omega j omega is a transform of x of t and h of j omega is a transform of h of t, then the product of x of t and h of t is transferred into 1 by 2 pi times its the convolution between the individual transforms. Okay, so x of t, h of t is transferred to 1 by 2 pi times x of j omega convolution h of j omega. So here also we can prove that. I am doing like, I can prove the statement, find the Fourier transform of x of t, h of t. Okay, so I am having the product signal x of t, h of t. Its Fourier transform is from minus infinity to infinity x of t, h of t into e raised to minus j omega t dt. Okay, now I have the product signal x of t and h of t. I know that h of t is transferred to h of j omega. Okay, therefore I can write my h of t as equal to 1 by 2 pi integral over omega from minus infinity to infinity h of j omega e raised to j omega t d omega. So this is the expression corresponding to h of t according to inverse continuous time Fourier transform. So here you have omega term. So in order to differentiate this omega from this omega, I am taking this omega as omega 1. Okay, now I can write this particular equation. This is equal to integral over minus infinity to infinity x of t I am taking as set and h of t I am substituting like h of t is equal to 1 by 2 pi integral over omega from minus infinity to infinity h of j omega e raised to j omega t d omega. This is actually h of t into e raised to minus j omega 1 t dt. Okay, so this equation I can write like, I can change the order of differentiation with respect to integration with respect to t and omega. I can write like 1 by 2 pi integral over omega from minus infinity to infinity h of j omega into integral t from minus infinity to infinity. I have my x of t. Now I have e raised to j omega t and e raised to minus j omega 1 t. So here I can write like this is equal to e raised to minus j omega 1 minus omega 1 minus omega into t dt d2. Okay, so in this term, in this equation, if you have e raised to minus j omega t here, instead of this I will be writing it as x of j omega. Okay, so I can write this equation as Fourier transform of x of t, h of t, Fourier transform of x of t, h of t equivalent to 1 by 2 pi integral minus infinity to infinity. This is, remember, this is integral omega over omega into this thing I can write it as h of j omega into x of j omega 1 minus omega, j omega 1 minus omega d omega. So here this equation is of the form integral over 2 x of 2 h of t minus 2 d2. Instead of 2 you will be having omega in omega and j omega. Instead of t you will be having omega 1. So this equation, this particular equation I can write it as f of x of t into h of t. In x of t is equal to 1 by 2 pi times the convolution between x of j omega and x of j omega. Okay, x of j omega convolution with h of j omega. So hence we have proved the statement of the multiplication property, which states that performing multiplication in time domain is equivalent to performing convolution in frequency domain. So that is a multiplication property. This is the last property of the continuous time Fourier transform is a Parseval's theorem. It's a very important property and it is known as the energy conservation property. Energy conservation property. So you know the energy conservation theorem. The Parseval's theorem is a proof of energy conservation theorem or energy conservation property. Okay, so according to the property, integral minus infinity x of t h star of t dt is equal to 1 by 2 pi integral minus infinity x of j omega h star of j omega d omega. Okay, so here x of t is transferred to x of j omega and h star of t is transferred to h of t is transferred to h of j omega. Okay, therefore the statement will be like this. So we need to prove this. Starting from the LHS, it is integral from minus infinity to infinity x of t h star of t dt. H star of t dt. Now you have to prove this is equal to 1 by 2 pi integral over minus into infinity x of j omega h star of j omega d omega. Okay, so the thing is you have to substitute x for h star of t according to inverse equation. So I am writing like this is equal to integral minus infinity to infinity x of t. We know that according to inverse Fourier transform, h of t is equal to 1 by 2 pi integral over omega from minus infinity to infinity h of j omega e raised to j omega t d omega. Okay, so if I am taking x star of this, that means complex conjugate of this x star of t, I can write that as equal to 1 by 2 pi integral from minus infinity to infinity h of j omega or h star of j omega e raised to minus j omega t d omega. Okay, so I can write x of t into h star of t is 1 by 2 pi integral minus infinity to infinity h star of j omega e raised to minus j omega t d omega. Okay, this I can write it as this is equal to 1 by 2 pi integral minus infinity to infinity h star of j omega, then integral. So this is over omega and this is over t. I am changing the order of integration. So outside that omega will be coming, inside that t will be coming. So integral over t from minus infinity to infinity x of t. So here you have dt x of t e raised to minus j omega t dt into d omega. So this we know that this is x star of x of j omega. This is x of j omega. So I can write this as equal to 1 by 2 pi integral over omega from minus infinity to infinity h star of j omega. This term changes to x of j omega d omega. So hence we have proved that integral from minus infinity to infinity, this is over t. X of t h star of t dt is equal to 1 by 2 pi integral over pi from minus into infinity h star of j omega x of j omega d omega. So this is the proof of the Parseval's theorem. Then why it is known as energy conservation theorem is that, so here the statement of Parseval's theorem is integral over t from minus infinity to infinity x of t h star of t dt is equal to integral over omega from minus infinity to infinity x of j omega h star of j omega d omega. Okay, 1 by 2 pi is also there. Okay, now if I am taking x of t is as a complex function, so our assumption is x of t is a complex function, h of t is complex and h of t is complex. So this is the assumption. Now I am taking it as x of t is equal to h of t. Okay, I am taking x of t equal to h of t. So I can write the equation as integral minus infinity to infinity over t x of t, h star of t changes to x star of t dt is equal to 1 by 2 pi integral over omega from minus infinity to infinity x of j omega, x star of j omega, d omega. Now you know that if x of t is a complex sig function, if x of t is complex, then x of t into x star of t will be equal to mod of xt square. The proof is if a plus jb is a function and a minus jb is its complex conjugate, if I am taking the product, I will be getting a square plus b square the whole square. That means what? That means a plus jb, mod a plus jb square. Okay, so x of t into x star of t is actually mod xt square, or I can rewrite the equation as integral over t from minus infinity to infinity mod square xt will be equal to 1 by 2 pi integral over omega from minus infinity to infinity x of j omega into x star of omega, that also changes to mod of x square d omega. Okay, so if I am assuming my h of t is equal to x of t, then I will be getting integral over minus infinity to infinity mod x square t dt is equal to 1 by 2 pi integral over omega from minus infinity mod capital X square d omega. Okay, so now you have already studied that this is actually the energy of the signal in time domain. Okay, energy of the signal x of t in time domain. This, if that is the case, this is representing the energy of the signal in frequency domain. That means in time domain, the energy is obtained as integral over t from mod x t from minus to infinity mod x square t dt, and in frequency domain, energy is obtained as 1 by 2 pi integral over omega mod x square j omega d omega. That means what? Energy in time domain is same as energy in frequency domain, and therefore the energy is conserved or energy is preserved. Okay, that is why this theorem, Parseval's theorem, is known as the energy conservation theorem. So this is a very important concept. If you are asked to find the energy of the signal in time domain and frequency domain, you can use the statement. So this is the Parseval's theorem statement for a single signal, and it is giving the energy conservation theorem. And this is the statement of the Parseval's theorem if you are assuming two different signals x of t and h of t. Okay, thank you.